Hello everyone, I am Usha Rani. Welcome back to my channel. Today in this video, I am going to explain about sets chapter. Sets was developed by George Cantor. He was born in Russia. Now, what is set? Definition of set. A set is nothing but a well-defined collection of objects is nothing but set. Well-defined collection of objects is nothing but objects or elements. Both are synonyms. What is nothing but well-defined collection of objects? Is nothing but all objects or elements having same property. For example, a group of even numbers less than 10, that is one set. A group of odd numbers less than 20, that is another set. Or a group of students who got less than 20 marks, that is another set. Number of students or group of students in the 8th class, that is another set. Like that, these are all the examples. Now in these, what are the main key points in the set? What you have to remember, the set is represented by the symbol like this curly symbol. Sets elements objects are represented in the curly symbol only, and set is represented by the capital letters only. A is one set. A equal to like this. What is the set? A, for example, 2, 4, 6. These are the 2, 4, 6. These are elements or objects. The elements are separated by the commas only. So A is one set. So set is represented by the capital letters. And suppose any alphabets are there, A, E, I, O, U. This is another set. The elements or objects are denoted by small letters, are represented by the small letter, but sets are represented by capital letters. This one thing we have to remember. And the symbol of set is curly brackets. And representation of sets. Here, two ways we can represent the sets. What are those? Representation of sets. What are those? Just we will see. In these two ways we can represent the sets. First one is roster form. Second one is set builder form. Second one is set builder form. So, what is roster form? In this roster form, how can you represent? In the roster form, we have to represent the elements by putting other or by separating the commas only. Here, for example, in the roster form, A, B, C, directly elements we have to represent. Those elements are separated by putting other commas only. And this is the roster form. Second one is set builder form. How can you represent in the set builder form? Example here, set of all natural numbers. Set of all natural numbers less than 5. This you have to represent in the set builder form. How can you represent here? Just curly bracket. In this x such that x is an element that belongs to what you have to represent. These are a set of all natural numbers. Natural numbers is set. Natural numbers are the elements. So natural numbers are related by the symbol capital N, and this condition is here less than 5. Like this you have to represent. So in those two ways we can represent the sets. One is roster form and second one is set builder form. In the roster form, directly you have to represent the elements. Those elements are separated by putting the commas. And set builder form, in this condition they will give you. According to that condition you have to represent like this. X is always an element that belongs to what you have to represent here, and that condition, whatever the condition is given, that condition here you have to represent. Here less than 5, natural numbers less than 5, so n less than 5 you have to represent. This is a way of representing the set. Next topic is types of sets. In these types of sets, first one is in this null set. First one is null set. or empty set. Null set or empty? Empty, nothing, no element in the set. No element in the set. Null is nothing but nothing. Empty, nothing. So, like this only with the curly bracket you have to represent, or you can represent by the symbol phi. This we call it as phi. So, null set can be represented by the symbol phi or with the only curly brackets. Next one is singleton set. Singleton set means a set consisting of only one element. Then we call it as, that is the singleton set. That means one element in the set means that we call it as singleton set. Like this, suppose A is the element. This is one set. Or another way, 2 is the element. Like this, any other element, only one element in the set. That we call it as singleton set. Next one, finite set. Finite set means a set consisting the countable number of elements in the set. That we call it as finite set. Suppose here even numbers less than 10. For example, here 2, 4, 6, 8, like this is there. So, up to 8 I have written here, no issue. 2, 4, 6, 8. Like this is the finite set. Here you can count the number of elements. 1, 2, 3, 4. These are the countable number of elements in the set, means we call it as finite set. Next one is infinite set. Uncountable number of elements in the set, we call it as infinite set. For example, here 1, 2, 3, 4 and so on. So on means this is uncountable. We can't count the number of elements in the set. That we call it as infinite set. Next one, equal sets. That means both the sets are having the same number of elements. That we call it as equal set. A and B sets have the A and B sets are there. Those two sets have the same number of elements and the same elements are also are there. Those we call it as equal set. For example, here A equal to 1, 2, 3 is one set and B set is 2, 3, 1. Here same element in both A and B sets, equal and same number of elements are there. Here 1, 2, 3, here also 1, 2, 3 and the elements also 1, 2, 3 only. So we can say that those are equal sets. And next one is disjoint sets. Disjoint sets means in both A and B, no common element in the sets both A and B. Then we can say that those are disjoint sets. For example, A equal to 2, 4, 6. These are the elements. And B equal to 1, 3, 5. Just take it here, A all even numbers, some 3 even numbers are there. In the B set, 3 odd numbers are there. Any common element is there? No. No connection, no joint in between A and B sets. So those sets we call it as disjoint sets. Now, next one is cardinal number. What is cardinal number? That means the number of elements in a set is called a cardinal number. For example, here set A equal to 1, 2, 3. Here set name is A. Number of elements equal to how many? 3. This can be represented by n of A. Cardinal number is represented by n of A. Here set A, you have to represent A. That means n equal to how many number of elements are there? 1, 2, 3. You write cardinal number of set A equal to 3. This is the answer. Cardinal number is nothing but number of elements in a set is called cardinal number. So that is represented by small n of that set name. You have to write and count and write the number of elements. That is nothing but cardinal number. Next one is universal set. What is universal set? A set which consists of all the sets under consideration is nothing but universal set. Universal set is represented by the letter mu. A set which consists of all the elements or all the sets under consideration. This is represented by like this. Mu. This is mu universal set. For example, here first natural numbers. Natural numbers under whole numbers. Whole numbers under integers. Integers under rational numbers. And another one is irrational numbers. Those are all we call it as mu. Mu is the universal set. Just I represented natural number, whole numbers, integers and rational number. These are all under mu. So mu is a rectangular box you have to represent. That is the universal set. And next one is subset. What is subset? Subset, for example, A equal to here 1, 2, 3 is the 1, 2, 3 are the elements in the set A, and B equal to 2, 4, 6. So subset is nothing but the element in the set A belongs to set B also. Then that we call it as the subset of this A is subset to B. But here only 1, 2, 3. Here also you have to represent here 1, 2, 3, 4 and 5. That means A set elements, all elements are there in the set B. Then we can say that set A is subset to set B. The elements are there in the set B. Then we can say that A is subset to B. That means you can represent subset symbol is like this, A subset to B. That means these are all elements are there in the set B. Then we can say that the set A is subset to set B. And one more important topic, next one is Venn diagrams. The Venn diagrams, these are the diagrams. These are used for the representation of a relation between the two sets. So, how can you represent that Venn diagram? Just like this you can represent. Anyway, you can represent like this. This is always mu set. This is A. Like this you can represent. Here in this, for example, union of sets and intersection of sets. Union of sets. Union is nothing but that is represented by the symbol U. Union of set means suppose A and B different sets are there. A union B means the combination of all elements in the set, that we call it A union B. Collection of all the elements in one set, that we call it as union. Suppose here A equal to 2, 4, 6 and B equal to 1, 3, 5. These are the elements. Now you have to find out A union B. Union is collection of all the objects or all the elements in the set, that you have to write in the order 1, 2, 3, 4, 5, 6. This is union. All elements you have to write, collection of all the objects or all the elements in the set. We call it as union. This how can you represent in the Venn diagram form means just draw the universal set. In this set A, one set, this is set A and this is set B. In this set A, what are the elements? 2, 4, 6 and set B 1, 3, 5. Here A union B is required. Union means collection of all. So just you have to write down like this 1, 3, 5. This is B. And this square box we have to represent as mu, that is the universal set. So union B means just you have to, what is the answer? A union B means all elements have to write in the order. Collection of all objects. This is union, A union B. Now intersection of sets. Intersection is nothing but common elements in the both sets. What are the common elements are there in the given both set? Those we call it as intersection. Intersection is represented by the symbol like this. So how can you represent? Suppose here example A equal to 1, 2, 3, 4, 5 and B equal to 2 and 4. Now what is A intersection B? A intersection B equal to, what are the common elements here? 2 and 4. So just you have to write down 2, 4 only. Common elements 2 and 4 are there. Here also 2 and 4 are there. So those common elements you have to write down. That is intersection. Common elements in the given sets is nothing but intersection. This can be represented by here A set and B set. Just draw the rectangular box. Here A, here B. In A, what are the common elements? 2 and 4. Whatever the common part is there, here you have to represent 2, 4. And remaining elements in this circle, first circle belongs to set A and second circle belongs to set B. In the first circle, 2 and 4, in the common part I already represented, and the remaining elements you have to represent here. 2 and 4, remaining 1, 3, 5. In the B set, any other element is not there, so leave it. What is the common part is there? That is nothing but the intersection. So A intersection B equal to 2, 4. This is the shaded part. The representation of shaded part is nothing but A intersection B. Here the representation of shaded part is nothing but union. Here A union B equal to all elements you have to write down. 1, 2, 3, 4, 5 and 6. Here intersection means only the common elements you have to write down. Next topic is difference of sets. A minus B and B minus A. A minus B and B minus A. Difference of sets means this is one set. Those elements are belongs to only A only, not B. So here A minus B equal to how much? For example here set A equal to 1, 2, 3, 4, 5 and B equal to 3, 5. Now A minus B, 3 and 5 here in the B set are there, those you have to cut. Remaining elements what are there, those you have to represent, where A minus B equal to 1, 2 and 4. That means the elements are belongs to A only, not to B. The elements in the set, that is one set, the elements in this set belongs to A only, not B. Just again you draw the universal set and A and B here. In this A and B, here just you have to represent like this. What are the elements? 1, 2, 4 you have to write down, and 3 and 5 just leave it common elements. So the shaded part is nothing but the A minus B, where A minus B equal to 1, 2, 4. Next B minus A. B minus means the elements are related to or belongs to B set only, not A set. Suppose here B equal to A, B, C, E, F like this. A set equal to, here set A equal to, set A equal to, just you write in the order. B minus A means first B you write, next A. So A equal to B comma C. Now B minus A means what are the elements of the A element, those are there or not in B set, just you have to check it. B is a cancel, C also is there, you have to cancel. Now again you have to write, draw the diagram. This is Venn diagram A, B. In the B set, common elements just you write here B and C, and remaining elements A, E, F. These are the elements in set B minus minus a, where b minus a equal to a comma e comma f. And last one is fundamental theorem. Fundamental theorem. What is fundamental theorem? NA, fundamental theorem, one theorem. NA union B equal to NA plus NB minus NA intersection B. This is the last formula. Fundamental theorem, NA union B equal to NA plus NB minus NA intersection B. This is the formula. These are the main key points in this sixth chapter. Just you have to learn properly, and tomorrow I will start the topics. So individually, one by one, what are the important questions are there, and whatever the questions are repeated in the board exams, those are all tomorrow I will start. I will make in the another video. So if you like this video, please like, share and subscribe my channel. Thank you all.